In this video, I'm going to talk about the first derivative test. So let's assume that we have a function f that is continuous on some interval, okay? And it has critical points at that interval. And what is a critical point? A critical point is a point where the derivative is zero or undefined. In our case, it will be zero derivative. So these are the three conclusions. So let's work with each of them one by one. So first one, if f prime of x changes from positive to negative, at a critical point, C, then f has a local maximum at C. The best way to get a feel for it is actually by graphing a function. Let's say you have a function f, okay, that looks like this. And let's say this is my critical point C, okay, where the derivative is zero. Let's now look at the left side of point C. So you can see that if you draw a tangent here, the slope of the tangent line is positive on the left, okay? And that tells me that the derivative f prime of x is greater than zero. On the other hand, if you draw a tangent line on to the right of point C, you can see that the tangent line has negative slope, or the derivative is less than zero. So you can obviously see visually that this is a local maximum. Similarly, we could draw another diagram that looks like this, okay? And for this point, let's say this is my C1, let's call it point C1, where the derivative is zero. Now look at this. We are going to go ahead and draw tangent line again. To the left of point C1, if you draw tangent line, you can see that the slope of the tangent line is negative. On the other hand, which means the derivative is less than zero. On the other hand, if you draw tangent line to the right of C1, you get a tangent line with positive slope, meaning that the derivative is positive. So if on the left, if it is negative, on the right it's positive, then the point of interest, the critical point, in this case C1, right, is a local mean or minimum. And here it was local maximum. Now let's consider the third case. Let's say you have a function that kind of looks like this. Here the critical point is gonna be, let's call it C2 here. Now to the left of C2, you can see the slope is kind of positive. The slope of the tangent line is positive, so meaning that the derivative is greater than zero. And here the derivative is zero, but to the right of C sub 2, you look that the slope are also positive, okay? So in this case, what's happening is that to the left of point C2, the derivative is positive, or the tangent line has positive slope, and to the right of point C2, the slope or the derivative is positive as well. So in this case, we really don't have a local maximum or minimum. So no local max or mean. So this is one scenario. There is another scenario you could, by the way, think of, which can be looking like this. So let's say you have a function that kind of goes like this. And with this one too, by the way, to the left of the critical point. So let's say this is my critical point C, okay? So let's call it C3. To the left, look, this slope is negative, right? The slope of the tangent line. And to the right, also the same. The slope of the tangent line is negative, making the derivative having the same negative sign on either side of C3. Again, no local max or min. So this covers all three scenarios, by the way. So these diagrams or sketches that kind of shows what happens in an actual function. So visually, this is very helpful. So all these three conditions or three conclusions could be seen in these figures. So just to summarize, if f prime changes from positive to negative at the critical point C, then you have a local maximum at C. If f prime changes from negative to positive around critical point C, that means on the left it's negative, on the right it's positive, then it's a local minimum at C. If f prime doesn't change sign on either side of the critical point C, then it has no local maximum, nor does it have a local minimum. So this could be on the left of the critical point positive, on the right of the critical point positive. It could be on the left of the critical point negative, on the right of the critical point negative. In both of these scenarios, you have neither local maximum nor local minimum. I hope that this discussion was helpful. Thank you very much.